Here's Joe Gray.
Thank you very much. Wow, that was a little bit louder than I expected. No worries. I'm kind of used to the whole projecting my voice thing, so I'll just dial it back a little bit. Anyway, welcome everyone. I will announce, I'm saying this tongue-in-cheek, that Scuba Steve is in third place in the Intel Village CTF. But anyway, that's been a running joke in the CTF, so I saw him back there, I had to do it. Yeah, so anyway, welcome to NetflOSINT, taking an often overlooked data source and operationalizing it. So to get started, who am I? I am Joe Gray. I start a new job Monday, so I'm not going to talk about that. We'll just say I work for Bruno, because we don't talk about Bruno. But anyway, beyond that, I'm the founder, principal instructor, and content developer with the OSINT. I am the author of Practical Social Engineering, and I'm a veteran of the Navy Submarine Force. I was just having a conversation before you all filed in about float testing things, brought back a lot of memories. Beyond that, certs, yep. Basically, I'm all about researching pretty much anything that ends in int. So beyond that, I've competed quite a few times. I'm the winner of the 2017 DerbyCon SECTF, two-time winner of the Trace Labs OSINT Search Party at DEF CON. Most recently, we got second place in the competition last weekend. So, why this talk? Well, I've been unemployed since December. Fortunately, like I said, Monday that changes. As a byproduct, I've been getting put through the paces for a variety of different positions. And with them, I've been asked to, in some cases, perform technical assessments to analyze random things, basically, to see if where my investigation abilities lie and whatnot. I was provided some data and asked to make sense of it, which got me in a research frenzy. And with that, I kind of picked up on the network forensics perspective. Full disclosure, in the past, I totally avoided network forensics because I just thought about it as logs. It's like, well, that's kind of boring. That's kind of lackluster. But then I started diving in a little bit more, and that brought up things like PCAPs. And if you've ever played with anything like the Active Countermeasures website, specifically Malware of the Day, PCAPs are it didn't happen. PCAPs are a truth, very similar to OSINT, or I'm sorry, DNS from an OSINT perspective. It is a truth. So with that, going back, restructuring my thoughts on network forensics, that would lead you towards PCAPs and logs. I'm not going to dispute the importance and validity of those, but you've also got Netflow. And with Netflow, that's something that kind of gets overlooked. It's somewhere in between the two. And you have some devices that will natively generate it, either in Netflow or IPFIX format, but do we really analyze the data, right? Are you bringing this into your SIM and making heads or tails of it? Sometimes you are, sometimes you're not. It's kind of like a Mounds and an Almond Joy, right? Sometimes you feel like a nut, sometimes you don't. It happens. So in this presentation, I'm going to start out kind of like with the basics, a basis of network forensics, talk about what is Netflow, and my computer is being dumb. Give me just a moment. There we go, back to that. For whatever reason, my browser's trying to close, so it'll be all good. We'll be fine. Anyway, we're going to talk about what is Netflow, a comparison of packet captures and Netflow. I'm not sure if I like the word extracting. I think the better term might be inferring Netflow from packet captures. And then we're going to walk through some analysis, and then to come back to, let's just face it, the clickbait title of NetflOSINT, logical jump-off points where you could do other things. So with the basis of network forensics, like I said before, we're talking about logs, packet captures, and Netflow. So logs, very simply, just like logs for anything else, it's evidence generated from a device, whatever type of device it may be. It could be a router, switch, firewall, whatever. It memorializes that an event took place. One of the main problems with logs, they're often misconfigured or not configured, and they can be deleted. With packet captures, it collects everything in a defined format that you can further analyze. Netflow, it's metadata. I think we can all think back to when Edward Snowden did his leak and metadata was in the news and it became kind of a boogeyman. Realistically, all it is data about the data. It's data that describes what is going on. With this, though, we have the ability to look at it from north-south, which would be ingress and egress, or east-west, which would be your lateral movement. So when we look at this from a perspective of pros and cons, logs are great, and they are considered universal truths until they aren't. Like I said, they could be misconfigured or not configured. They can be deleted. You have things like time stomping that could take place. I mean, a wily adversary could very easily do something like set an awk or just anything to do a replace all and put everything as 1/1/1970. I mean, that would actually be kind of fun. But they vary in file size. They can get pretty big, but in the context of what we're talking about today, they are considered small-ish. But it also depends on your topology, the configuration, the verbosity, various other factors. PCAPs, they're great. I'm not disputing anything of that. I'm not telling you that you should be looking at Netflow over PCAPs. This is not a this or that conversation. This is a conversation meant for this and that. So they do show the complete picture. There are some exceptions through the use of encrypted protocols because you would have to have some means to defeat that. By defeating it would probably be you have access to the decryption key. But you can still infer context from it even if it is encrypted in some cases. If nothing else, it's going to tell you that something occurred. The problem with it, it's a large file size. I learned this downloading malware of the day samples from Active Countermeasures site because in some of the exercises, they have a 1-hour PCAP that you can start with, and then they have a 24-hour PCAP. They vary greatly in size. Also, depending on where the PCAP is captured, where the packets are captured from, that can affect the size as well. And quite honestly, you're going to pick up a lot of noise as well. You can do great analysis with it. Wireshark has the ability to follow streams. There's all sorts of things to do, but it's difficult to perform statistic analysis on, and that's what we're focusing on here. So with Netflow, also IPFIX, it's native to many devices. It's often not used in favor of PCAPs or logs. With that, in comparison to PCAPs, it's a smaller file size. And it does have less visibility. With a PCAP, say you connect to something via HTTP, via PCAP, you're going to be able to see everything, right? It's not encrypted. With Netflow, you're going to see the time of the transaction, source, destination, and the size of the actual transaction. That's what you're going to see. You're not going to see what the transaction was. You're just going to know there was a transaction. But because with Netflow, you can very easily get it into CSV format, it's a lot easier to analyze. So with that, let's talk about what Netflow is, and here's a brief history. So it's originally a Cisco thing from the mid-90s it was built for troubleshooting. It's just like most things in this industry, right? Most of the things that we're talking about in conferences, it all started out as something legitimate and someone found another use case for it. So it was meant for troubleshooting, it's still meant for troubleshooting, but you also can find an alternative use case for it in security monitoring. It's very similar to something like websites used for sales and marketing leads. That's a really good place to find some pretty solid OSINT on. It's the use versus the abuse. But with this, there are 3 required components of Netflow, and that would be the exporter, collector, and storage, which the storage part shouldn't be surprising. Basically, Netflow has several versions. Netflow version 9 is the second most common. Number 5 is the most common. The big difference is the verbosity and which fields are included. IPFIX really doesn't have anything to do with Netflow, but it is technically Netflow version 10. So with that, here are some typical fields of Netflow. Time, source, destination, for both IP and port. You also have the protocol, the type of service. You may see it in terms of bytes. It may be listed as octets, or it could just be the number of packets sent and received. Comparing Netflow to IPFIX, basically, this is basically the same thing from the previous slide, but the other thing is, it's kind of like a Kleenex or a Q-tip, right? There are other facial tissue companies out there, but generically, it becomes a Kleenex. There are other cotton swabs, but we tend to call everything, regardless of where you get it and the brand on it, a Q-tip. So basically, that is the case with Netflow, especially in its relationship with like IPFIX. So to compare PCAPs and Netflow, basically, with Netflow, it's going to abbreviate the story. It's kind of the TLDR, if you will. It is looking at it from the strategic perspective as opposed to the tactical perspective, which would be more akin to PCAPs, which would be at the micro level where you have a lot of verbosity. As stated before, with Netflow, you're going to have the smaller file sizes, but you can very easily import that into a SIM or drop it into as a CSV file. And with that, I mean, you could do all of the analysis with Netflow in Excel or OpenOffice or whatever. You don't have to use any of the stuff I'm going to show you towards the end. It's easy, but it doesn't include the contents. With PCAPs, you can do file carving, you can follow streams, you can create verbose filters, but it is a larger file size. And as someone who collects a lot of stuff, typically because of like my investigations dealing with OSINT, I became kind of hypersensitive to file sizes because if you collect it, you have to store it. If you store it, you have to secure it, and all of that costs money, right? Because you can erase things, but at some point you're going to run out of space and you're going to have to go buy more storage. So with that, it's not always logical to store a massive PCAP. You might want to filter certain things out and then create a smaller file to retain. But with both of them, they are both valuable. That's the important part. So to extract Netflow from a PCAP or to infer, basically, there's a few tools that would be needed for this. Honestly, I use the term scripts, but it's literally just 2 commands. And with that, you'll need a packet capture, a Linux host with Silk, and then optionally, something to the effect of Excel, a SIM. For the demo piece of this, I'm using Elk. Specifically, I registered for a 14-day free trial of Elk, just because sometimes configuring Elk can be a beast. You could also do this with something like, say, Splunk, and other SIMs as well. And then the alternative would be using Jupyter Notebook with pandas. So with it, you go to your directory that actually has the PCAP, or you can use the full path. You're using RWP to flow, and then you give it the path. Don't worry about this knowing the syntax would be great, but I'm going to show you operationally momentarily via a pre-recorded demo of this. But basically, you tell it flow out, you give it a path, that part's done, it's going to create an RW file. At that rate, then you say RW cut, comma delimited, give it a timestamp format, in this case, ISO, output path, there's your CSV, and then the RW file that you're feeding it. Once that's done, you've got a CSV file to analyze. Take it, Excel, Jupyter, your sim, whatever you choose. No big deal. You'll be fine. So, and I don't know why that just replicated. So we'll take a look at how to actually do this. So bear with me a moment while I rearrange things. So this is the recording. So as you can see here, it's RWP to flow, and then the actual directory. So PCAPs, I used evil OS10 1 hour PCAP, which, full disclosure, I did download from Active Countermeasures. It's one of the malware of the day PCAPs that you can analyze. From here, flow out, so I gave it a path, and then there's the RW file. And then from here, there's the RW cut, so the delimited into a comma, timestamp format ISO, there's the CSV, there's the RW file, and that's pretty much everything that we have to do. And then from here, just moving around, there we go. Yeah, even with a demo, I left it imperfect. But now you can see here's the RW file and here's the CSV. So that's everything that we need. So as a byproduct, with that, it's fairly simple to do. Like, there really are no hardcore variables or anything that you have to put in. You just have to know the file name and the directories you want to put it in. I use convoluted files, directory structures in everything. I really wish I didn't, but that's just how I'm wired. So my command was a little bit more, oh, I thought we were back on this. I thought, or I'm sorry, my command was a little bit more complex than yours would have to be, but that was just by my own choosing and design. So if we want to analyze this stuff, here's how we can do it, via Excel, ELK, or Jupyter. So with Excel, you probably already have Excel or some other program that functions like Excel. So you can use it to easily filter and sort and organize the data. You can sort it ascending by file size, ascending or descending by time. You can filter based on certain IP addresses. You can write formulas for frequency analysis. You can do everything there. You can do everything there on, realistically, any device. Windows, Mac, Linux, doesn't matter. With ELK, it's going to bring in visualization. You can build your own visualizations. You could do that within, honestly, Excel. You could do that within Jupyter Notebook. You could do that using Matplot, or, I mean, something like ELK, it's already there. And you can also, the beauty of, for the purpose of this presentation with ELK, if you're ingesting other data, such as log data, you can cross-correlate that and use this to enrich your other data, which ultimately, I'm not going to use, I mean, this is not Black Hat. I'm not going to talk about any single panes of glass, any shifting left. There's nothing advanced persistent or next generation about this. It's just the here and the now. But with that, it does give you better context, and context is key for anything, because ultimately, we just want to do our jobs and we want to do it securely and effectively, and this is just another way to do that. With Jupyter, it can be a bit more complicated unless you already have Jupyter, but you do get better statistic analysis because Jupyter comes to us primarily from the data science world. Jupyter basically is Julia, Python, and R. Python and R being pretty heavy data science languages. That's where I picked it up. So it's a little bit more complicated, but you do get that statistic analysis. And you can reuse the same notebook and the same scripts for a variety of PCAPs. Literally, you change the file name and you go with it. That's all you have to do. You can change the file name of your notebook, or you can change the file name that you're ingesting. You have the steps preloaded. Play, 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 play. You're done. It's good. No big deal. So that's the thing about Jupyter. You could do this from Python as well. And to be honest, just to be entirely transparent with it, with Python, realistically, you could just load the PCAP directly in using Scapy and do some of the same analysis, but based on some of the things I've done with Scapy, you've got a lot more steps that you would have to go through, and it's not necessarily as clean and painless. This is something you can do in a relatively short period of time without issue. So with that, we are up for another demonstration. And this one will be another pre-recorded video. And this is just ingesting into ELK. So upload a file, give it the file name, there it is. So that's everything. You can see the CSV tells us all the fields that are there, so that's the index for it. So you give it a name. The other thing to know about like Netflow and this whole like kind of discipline, if you want something directly out of the box to use on the network, you can download from SANS. They have a VM called SOF, Sierra Oscar Foxtrot -ELK, and it's an ELK instance that you can ingest and has a lot of this stuff in it already. So to that end, it's already got ELK set up. The thing is, you can't really easily get the file loaded into it because the fields are different. You would have to go through your CSV and alter the headers, basically. So with this, it comes in. We have the data view. I'm going to jump us ahead so we're not sitting here on an 8-minute demo. So this is the data as it's in. And we've got everything. So now we can move to a dashboard and create a visualization. This is how easy it is. You literally drag and drop the field that you want to analyze. So in this case, what we have right here, these are your top 5 talkers in this PCAP. So you can look for things and say, you know what, looking at the other 4, one of these seems to be an anomaly. Do you all tend to agree with that thought? But the thing to keep in mind is over here you have client IP address, destination IP address. Further down there's a source IP address as well. So client is taking into account source and destination. So while this does look to be an anomaly, and as I recall it is, looking at it at client IP address is looking at both sources and destinations. So therefore, if say like this is a common host that people are, or the hosts have to communicate with, that may not be an anomaly. But anyway, with this, here's the destination IP address. Notice other's huge, so it looks like an anomaly there, but it's not. Now we're looking at destination. It's different. So we can reasonably say that yes, this is an anomaly. But we can also verify that the IP addresses over here are different in each pane as well, which gives us that additional context. So as we go through it, with this one, we can look at whatever. So with this destination port data, port data comes out a little bit tricky at times. But like right here, it calls it octets. So right here, we can see the mean or the median or the standard deviation of the size of the packet, right? So before we get to Jupyter, I'll just, point it out from an analytic perspective. From a statistic perspective, the mean is the average, right? It's the number to most generally describe the consensus of a data set. the median is basically the centermost data point, right? Standard deviation is taking that into account to describe how normalized something may be when expressed in a natural bell-shaped curve. So if you see something where the mean and the median are very similar, you have a fairly consistent data set. If you have variation between the two, that actually gives you indication that there could be some anomalous activity. So with this, what I'm getting at is knowing what your mean and your median transfer size is. In this case, we see it's 114,000, right? Well, when you look at the larger file sizes and you see someone moved 4 billion bytes, that's significant. You know, for any statistics nerds, that's greater than plus or minus 3 standard deviations from the mean, which would be an outlier, which that's something that you should be honing in on. But that's what we're getting here. And basically, this is just building the dashboard for us. Using ELK affords the opportunity for multiple people to log in and see it at the same time. It affords the ability to export these as image files to put in reports and impress management and look like a rock star. Or just people, I mean, everybody learns differently, right? Some people learn by hearing, some by seeing, some by reading. Anytime you're reporting, doing as many of those as possible is to your benefit. So ultimately, right here, we're seeing basically the same thing, right? But we're seeing this is based on source IP address, and you can slice and dice this as many ways as you want. And once you build this dashboard, right? Once you have it built, then you can very easily, as you ingest new data, it'll populate it, right? So there's the median and there's the average. Anyone see any issue with that? So if it were skewed the opposite direction, that may be indicative of beaconing or some form of C2 or something to that effect, someone running ping sweeps or like port scanning, whereas seeing it skewed this way would indicate possible data exfiltration or something to that effect. But nevertheless, these are all just graphical ways to view this. And then here's Jupyter, but I've got Jupyter loaded live, so I'm just going to move to that. And apparently my Jupyter disconnected. Bear with me just a moment. All right, so we're good. So with this, it's a Python script. I've loaded it. Literally, we press play, and okay, everything's imported. Setting a few parameters here, no big deal. So right here, we bring the CSV into a Python data frame. If you're not familiar with pandas and data frames, a data frame is basically an Excel spreadsheet in memory. That's probably the most simple, grossly oversimplified definition of what it is. But anyway, we do that, and then I just give it a name. I give it the encoding as well. So we accomplish this. Now we've got everything here. So we can look at the top, this is not the top 5 events, it's the first 5 events. Now we can look, by changing this, instead of the first 5, we give it a second to run, we're going to get the first 45. It shouldn't take too long for 45, but let me restart this kernel again. Sometimes it gets to thinking too hard on us. That may be the case. We'll watch for this star to go away. We'll give it a moment. But you really don't have to import a whole lot either. It really just depends on what you're trying to accomplish with it. Like, honestly, I've got more imports on this than I really need. All I really need would be pandas and, well, actually, just pandas, really. But it is kind of what it is. One moment, let me check the host. There's the problem. Oh no, I need to update my cloud instance. That's okay. If I leave it unupdated on the web, I'm sure some nice folk of the internet will be polite enough to update it for me and probably make sure my passwords are properly audited and updated. So there we go. We'll be good now. Going back over here, let's restart it again. And we'll run it. It should work this time. If not, again, I've got the screen recording. Perhaps I didn't make the appropriate, there we go, there it goes. So I was going to say I may not have made the appropriate sacrifices to the demo gods, but I was wrong, which is good. But anyway, we print it, or we load it right here. We're going to view the first 45 records. He's dead, Jim. Honestly, the head command with pandas, it's something that you really don't need to do often. It's something that you're going to do more, you're more apt to do it for the purpose of validating your data, that it's there. And honestly, we won't worry about fighting with that because I've got the screen recording here that we can operate with. Or I thought I did. No, I guess not. Anyway, no worries. So here's basically what the dashboard at Elk would look like. And I'll go back over to Jupyter. I can at least talk you through it. If Jupyter doesn't want to cooperate, I can at least show it to you. I'll give it one last chance. But with this, the output's already there, so if the commands don't work, it's no big deal, right? So with this, the head command, we're not going to see that, but literally that's the top X number of things. From here, these are the first 4 IP addresses. Do not confuse that with the top 4 talkers, though. It's just the first 4 that occur in that particular field. From here, to get the mean, we just choose the field. So we use the data frame variable, the field num underscore octets. Dot mean, there's the mean. We saw that with elk. It's the same number. We can get the value counts. So right here, this is our frequency analysis. This is what fed that bar graph that we saw in elk. But basically, this is the statistic analysis that's going to say, hey, these are the top talkers. And if, for example, in your network, say you're in a small organization and Bob in accounting's been on vacation for 2 weeks and his IP address is 192.168.1.45 and it's number 1 on that list, that is probably something you want to investigate. Maybe. Just saying. Unless that's normal. Every time Bob goes on vacation, it happens, or if that's the norm, then it's the norm. But that's what you're trying to evaluate. And I love fighting with technology. And then it finally actually did what I told it to do. So let's try this again. Yeah, it's not going to jive. Oh, there it goes. I'm going to skip that head command. So there's your 4. I mean, we can change this from 4 to 10 if we want to and get more. So ever how you want to do it. There's your mean, right? But we can change that to median. Or you can even find out what your standard deviation here is. So there you have that. Here's your frequency analysis of source IP address. But, say for example, you don't want to do source. You want to do destination. Cool. Literally, you change the field and run it again, and it's the exact same thing. You want to know the ports in use. Say, for example, like notice right here, the second most used one. 443 is not uncommon to be number one. 500, anyone know port 500 off the top of their head? It's VPN. So from a corporate network, should be VPNing in, not out. So this would be VPNing out.
Yeah, but you're on network already.
Right, unless you have multiple sites. And if that's the case, that may or may not be the case. But either way, this is something that would give you indication of anomalous behavior. So going back to the whole concept of NetflOSINT, you now have context that you can hop into that PCAP with and filter things exclusively for this. This is the context. Like I said, it's not meant to replace PCAPs. It's meant to enrich and enhance your ability to investigate it. Continuing here, we have the same stuff with the value counts. You can do several other things, like right here, instead of unique with a number, you can say in unique, and that's going to give you the number of unique IP addresses as well. There's a lot of things you can do with pandas, but you've got to get used to it, and it can be a bit painful at times. But with that, resources to pick up on it, obviously your typical things like Stack Overflow, Google Dorking to find things about it, and then a resource I'm really fond of would be a thing called Towards Data Science. They've got some good tutorials out there, and I believe in the newest revision of his Python course, the Python for OSINT course actually, Justin Seitz actually covers working with pandas in it as well. And that's a low-cost, on-demand course that you could take if you're so inclined or interested. So with that, that was the demonstration. In terms of your next steps, in the interest of time, we'll just walk through it. At this point, you have context about an IP address. If it's an external IP address and you've got a Jupyter notebook, you can immediately, you could already have this staged in your workflow to have things to query this from Shodan, from security trails, see if there's any data breach information with it, depending on the context, right? You could also pull from things like Census, Shodan, a variety of sources. This can be very useful for threat intel as well, because you can use this in conjunction with something like, say, passive DNS, and understand more of, I don't really care about IOCs, looking at the pyramid of pain, it's more about the TTPs. It's not going to enumerate an adversary's TTPs, but it's going to give you a better glimpse into what they are up to in terms of things beyond, oh, well, it's this file of this size of this hash. Cool. I'll go and add like 3 lines of hello world and change your hash. We're good. It's not hard to change an IP address. Domains are pretty cheap. From what I hear, there are free domains that end in like .tk. Has anyone went to Walmart.tk by chance? I don't give it a solid 5 out of 7. I don't recommend it. Somebody ran HTTrack and did a very poor clone of Walmart.com. Oops, wasn't me, seriously. But you can put it in your reports, and the fact that you have that additional context around this, and you're able to look at this from a somewhat multidisciplinary approach and kind of think outside the box, this could, your mileage may vary, make you look like a rock star. That being said, does anyone have any questions? Questions, concerns, anything? Any questions? Oh, crap, hang on, my bad. I thought it was up on the screen over here, but there we go. That's what I was talking about. So your next steps, OSINT, threat intel, reports, and potentially looking like a rock star. If anyone has any questions, I can field them, but otherwise, here's my contact information if you want to get in contact with me. Okay, if there are no questions, thank you very much. Be sure to come over to the Intelligence Village. The CTF is going to continue until 2:30. There are prizes for first, second, and third. But beyond that, if there are no questions, thanks, and be safe.